Hey guys, welcome to the shop. We're back on the properly named scrapyard saw this week. I think that's a good name for it because that's probably where it should be. Start tearing into the sheet metal of this saw, tearing it down a little more, looking for more problems. You know, we get into the gearbox a little deeper. And of course, we do find more problems. I wouldn't expect anything else. Start machining the center hub for the pulley, start machining the pulleys themselves. I mean, you get the idea. A lot of work for sure. But I think it's maybe starting to go the other way. I don't know. You be the judge. But you'll see. Thanks for watching, guys. Let's get started. Wow. Man, that one's in there. There we go. Probably worth more than a saw. So check out those blade guides. Got two, of course, coolant to each one, which is pretty neat. They're definitely just the shoe style, I guess you'd call it. They're not bearings. Got a wear plate top and then on both sides, and then they're adjusted as far as how they squeeze the blade, how much they squeeze the blade by this screw here. So that's pretty neat. I wonder what those are. Maybe they may be carbide. I don't know why they would decide to use shoes instead of bearings. Maybe they're just, you know, in the long run more trouble-free or more reliable in a production environment. I'm just not for sure. But, you know, it's definitely heavy duty. Those are cast iron. So the same magician who's worked on this saw has had his wand in here messing around also. We're missing a couple screws. We've got some of that Permatex sealant oozing out, and I don't think Dual would have done that. Maybe they would have, but I'm concerned. So let's pull all this apart and look at it. I just think this is the back bearing cover for that gear in there, but while we're here, we might as well, you know, dig in. See, he's been in here for sure. That's just that back bearing cover. Why not work on this also? Look at that. Doesn't look very healthy. It's amazing how beat up that is. I mean, it got beat up exactly the same way I'm taking it off, but man. It's supposed to have a lock washer on this one also. So I'm going to have to make another one of them stupid things. Wow. I guess it's alright, but needs cleaned up, that's for sure. Alright, so there's really not a lot to see in there other than some goo. You know, that'll have to be flushed out really well. That's so nasty. But I found another problem. Of course I did. Let me show you on the other side. Alright, so this is the other side of that shaft with the big gear on it in the back that I just showed you. But when I pulled the gear off this, the gear that powers the main wheel, there was no seal here. So obviously they just didn't put a seal back in it. It needs a rubber lift seal here. So I'll have to figure out what size that takes and get one for that. I can see where one had ran in the past, so obviously no seal here with all these metal chips wouldn't work. So I'm just cleaning up this gearbox cover. Cleaned up pretty good. And, it's got a broken bolt in it, unfortunately, that I have to try to get out. It's not a through hole. I don't have any left-handed drill bits, so I'm going to have to come up with another way to get it out. So I'm set up in the mill here, just centered up, by eye. And before I try to drill this thing, seeing as I only have right now standard right twist drills, that will, just the act of drilling it will screw it into the hole harder. And if this thing's not in there too hard, I'm hoping I can remove it with another method. And seeing as it's protruded a little bit, I'm going to take this sharp needle file, just one with a good sharp 90-degree cutting edge on it, and I'm going to file a blade on this thing, like you would see, like a straight screwdriver, and try to grab it with some flat-bladed needle nose pliers. I'm going to do that first because I'll lose this option if I drill it. So let's try this, and then I'm going to take myself inside and order me a set of left-handed drills. I'm sick of not having them. Alright, so I just got two little flats on there. I'm going to heat it up a bit. There we go, it worked. Better than taking a chance of drilling it, I guess. A little warm. Of course, I did it. There we go. Glad that worked out. So it went online, just your standard auction site, and I ordered a set of cheap snap ring pliers, Horusdy, Horusdy, whatever that spells, and you know, I got them in. I paid 15 bucks for these things, and I'd have to say that so far, you know, for 15 bucks, I can't believe they can sell them for that. We'll see how long it takes the ends to break off, but they actually feel pretty good. I've been using them a little bit, and I'll tell you what, if they get 10 snap rings out for me, I'll be happy. So there we go. That is done. They don't fit as tight as I'd like. I think I'm going to use some retaining compound on that. Just a little carburetor cleaner. This is just 641 retaining compound. That's all it is. Just like a metal glue, really. It didn't take much. This just seats against that snap ring down in there. That's it. I'll let that set up. Just heat it a little bit and it'll come out if you ever need to take it apart. So here's the motor starter that I showed last week that I pulled out of the Saw's original electrical cabinet, and as luck would have it, the coil on here, which I questioned last week, its voltage happens to be 120 volts, so that's fortunate, and I'll be able to use it. So here's you know, all it just sits in there like that through these laminates. It's got you know, the other part of it down in there, and it just pulls that together and makes a contact. So let me wire this up real quick. You know, I'll pull off this cover. I'll show you the actual contactors themselves, and you know, this thing in action, because it's pretty neat the way that it works. We're just going to energize the coil. That's all we're going to do. The rest of this, of course, will be you know, dead, of course. So all the guys that are familiar with electronics will have already have seen these, but talk about nice. I use these little connectors. They're Wago style 221 lever nuts is what they're called. Just a quick way to make a, you know, electrical connection that doesn't require twisting wires together or tape. And I mean, they're really nice and easy. I used them to wire the lights that I have in the shop here. So that's it. You know, no tape, no nothing. So let's get this thing fired up. I'll show you how it works. But I figured I'd share those with you too, because that's a good product. Alright, so under this cover is where the actual contactors are. You can see them there. And when I energize the coil, see how they just slam shut. So they're not in great shape. Got a little, you know, erosion and stuff on them, but I think probably be fine. That's it. That's how it works. So the machining is done on our two outer pieces. I just bored these out to 1/1000th over 2.8 inches, slightly over, what is that, a little over 71 millimeter. No reason for me to show you the machining of these. I showed this one last week. It looks exactly the same. Now originally these were slightly over 2.75 inches, which is the diameter of our center hub here. And you know, I just wanted to remove as little material as possible to get these things good true bores, or get true bores in these. Every pass we make just removes strength from these, and there's no reason to go any bigger than we need to. My center hub material, new center hub material come in. It's 3-inch OD, 2-inch ID, piece of 4130 that was sent to me by Eric Richards over at Turner Tooling. So I really appreciate that. Should make a good, nice new hub. Still have not got my bearing bronze in yet, but it is on the way. Gear cover, pretty much done. I mean, not a lot to do to that other than remove that broken bolt, seat our bearing race in, clean everything up, straightened out my little cover. Of course, it was bent, and new stainless steel hardware to go in there. Also cleaned the nut up, and I'm in the process of making a new keyed washer, which is not very fun, but it's about done. So, new bearings come in for the drive wheel. I decided to go with rubber sealed instead of the original metal shielded. I just believe these are a better candidate to avoid getting swarf in them, so we went that direction. So we'll have to install those also. So yeah, getting close. The center hub, the piece that, or the center pulley section is in the lathe right now. We need to bore it out to slightly over 2.8 inches, and then maybe we'll start working on our center hub here. So on my pulley halves here, to measure these bores in the lathe, of course I used the telescoping gauges, just the best instrument that I have to measure a bore of this size. And using these can be a little tricky if you're not careful, because the amount that you tighten this, the way that you rock it out, whether it's centered or not, it all plays in the final measurement. So you want to take several measurements with them. But these Starrett ones are really nice. I've had cheaper sets in the past, and they really don't give that quality feel that these do. And I think, for something like this, that's tough to use anyway, it's best to have a good set. So this should measure about a thou over 2.8 inches. And as you can see, we're right on the money there. So you can get very repeatable with these if you use the same technique, every time you use them. But there you go. So I've got the center section of the pulley in the lathe here and the forejaw. We're trying to dial this in as close as we can to match the original machine surfaces. This surface here, the outside, the OD, and then this inner diameter are concentric with each other. At least from my measurements, that's what I'm seeing. We've got a lot of damage around this edge that I'm trying to indicate on. So I'm going to show you how I deal with something like that, and get it as close as I can. And then we'll check the face and we'll check the bore, compared to the OD here. Let me get you in on this indicator a bit. Okay, so it's kind of hard to read this face with all the damage that's on it, but all I'm looking at is the maximum and the minimum reading on our clean surfaces, the ones, that aren't jerking the needle all around. So I'm just going around here, and what I'm seeing is about 1.5 thou. Maybe slightly more on the clean surfaces. But keep in mind, this is a tenths indicator, so we're within a couple thou. Pretty easy, I think. So I'm happy with that. Now let's check the face. So I'm within 2 thou on the face also. Now let's check the bore. So our bore run out here is pretty good, really. Let's see if we can get 0 there, or close enough to 0. Yeah, we just tried to average everything out as best we could. This bore is not that worn, so you know, I took more care with it than I did the rest of it. But there you go. Within a few tenths, it's going to have to be good enough. So let's get set up and bore this thing out to slightly over 2.8 inches. So I'm using a Kennametal bar here. This is a 1-inch bar, biggest bar that I have for this, you know, bronze bore. We're going to be using a brand new insert also. Anytime I cut bronze or anything, you know, I like to have a good sharp cutting edge with a good rigid tool. You know, this is tucked up as tight as it can be, still get through that bore, and you know, a good sharp edge. Wow, it's an awesome finish. Let you check that out. So check that out, and that's about as good as you could ask for. You know, I'll just continue. I'll measure this, see where I'm at, and continue making passes till I get to where I want to be. But check that out. It's pretty good. All right, so after that cleanup pass, let's see where we're at. You know, 71 millimeters or 2.8 inches, slightly over that, is what we're shooting for. Let's see where we're at so we can set our lathe dials and work from there, you know, from this point. So we're only removing 50 thousandths total, right around there from the bore was a 1.2 millimeter. We are 39.5 thou away from, you know, our final dimension, right around in there. About a what is that, 1 millimeter? So 1 millimeter. I just know that 1 millimeter is around 40 thousandths. I'm trying to get, you know, thinking in both imperial and metric. So there we go. You know, I hope that finish holds out to the end. We don't have far to go. Should be it. Good. So if you're doing round stock in the 4-jaw and you know its size, take advantage of these lines that are scribed on your chuck. They're in inch increments. So this is a 3-inch part. Just set it in there and line it up with the 3-inch line. Bring my jaw in there. And then I know that you know, it'll be a good place. It'll be a really good close place to start right there. You know, now I'm not going to be a mile off. You know, just sticking it in there real quick. So let's see how close we got just by using the lines that are machined into the face of the chuck. That's what they're for, of course, if you didn't know already. You know, just for quick lineup, quick reference. So wow, that is close. 25 thou. And, you know, not far to go and we'll be dialed in, so take advantage of those lines. I mean, they'll save you a little time on setup for sure. Wow, we got within a thou that fast. It's just luck, but let's see where we're at out of here. So 5. That's right on the money. I don't know how true this is, so we'll just get it as close as we can. We're going to be taking quite a bit off anyway. But I want to try to keep the center bore, you know, good too, assuming that they're concentric. Just kind of out around. That's alright, I can deal with that. We're still good here. Just for reference, I'm going to check the bore, see what it is, and then we'll start cutting this down. This is 4130. So 8 3/8 is our length on our original hub. We're a little over 8 3/4, 8 7/8. So we'll just peel this all the way down to about the chuck. That'll leave us room to part, and should be good to go. I really struggled with this 4130 in the beginning, trying to get, you know, a combination of depth of cut, feed rate, spindle speed that would give me the finish that I wanted on this stuff. You can see here I'm pushing up a burr. You know, that's a brand new insert. And, you know, I'm getting long stringy chips that are just whipping around. The finish was inconsistent. I was just unhappy with what I was getting, and I tried multiple things, you know, which I'll explain in a minute, to try to solve the problem. I had 200 thousandths of stock excess on this, which is not too bad. Sometimes you're not left with that much, but I was starting to wonder if I was going to run out of material before I figured out what would work or not. But, yeah, I finally got it. The soluble oil made a mess. So I've been doing a little trial and error, trying to get a finish on this material that I'm happy with. This 4140 or 4130 seems to like to be turned somewhat aggressively. A minimum of 10 thousandths on my depth of cut, and full speed on the spindle, which is a little around 500 to 550 RPM. And I'm around 20 thousandths of an inch per rev on my feed. I'm not sure on surface feet what that ends up to be, but you get the idea. So otherwise I end up with a finish that's rough. It's not bad, I can deal with it if I end up with that, but you know, you get the idea. I've got to turn this pretty aggressive. Cutting oil doesn't seem to make much difference, just smokes the shop up and doesn't really seem to aid in a better finish. Soluble oil and water, which I have on the lathe, just makes my finish worse. So it's a little tricky, but I think I've got it figured out. I just got to make sure to set myself up to have a pretty decent final cut, or else, you know, I'll end up with a finish that I'll have to polish out. So here's about 10 thousandths depth to cut, 10 to 12, 10 thousandths or 20 thousandths per rev on the feed, like I said. You know, it worked for me with the tooling that I had on hand to use. This was giving me a good finish, so I just rode with this to the very end, making sure to set myself up in the end to have a similar depth of cut to what's working here. And I was fully expecting that the insert on the very last cut would die about halfway through the part, because this stuff seems to be fairly rough on inserts, a lot of heat. But most of the heat was coming out in the chip and not going into the part, which was nice. It's perfect. Oh, man. Whew. Good. Check our end. And it's perfect. Yeah. That's what I was after. There's a ton of machining left on this. Snap ring grooves, keyways, we got a bore, we got to press in bronze bushings, I've got a counter bore for my inch lip seal, but this is going to have to be parted off. I'm going to have to work from one end to the other because this bore is way too deep to work with the, this is the largest bar that I got, which is an inch Kennametal bar, and there's no way it would work on this material with that much stick out. So we'll part it, work both sides. I'm out of time this week. But my material come in for my bronze bushings. I'll show you that too. Let me show you why this wouldn't work, obviously, to bore this in position like it is. Watch just the pressure of my thumb with this bar sticking out, 8.5 inches. 5 thousandths deflection. So you can imagine how bad that would chatter if you tried to do this bore in position. It would be ideal if you could, because right now I'm dialed in, but I can tense indicator this in, flip it, and get it good enough for what we need. But yeah, that would never work. So that's why we're going to have to work from one end to the other. So front wheel, or I guess you'd call it the idler, or the tracking wheel on the saw, it's done. I didn't show it, but installed the original bearings that come out of it. I did put new snap rings on them. If you remember, when I pulled this off, these bearings were completely recessed down into the bore of the pulley here, and the saw pulley itself was rubbing the body of the saw, and it was held on by a brass threaded collar with a set screw in it. completely wrong. I believe I've got it assembled correctly now, and minus paint, like on both front and back wheel, they're ready to go back on. So, you know, a little cleanup work and they're done. Still got to cut my keyways in both of the pulley halves, so that'll be a fun task. I'm not sure if I'll do it on the shaper or make a broach bushing for them and do it with a broach set. Here's our bearing material that's going to go into the pulley that we just cut. It is C954 aluminum bronze. It's a continuous cast material, 2.8 inches in diameter and 3 foot in length. Can be tough to machine. Good sharp tool is required, and a fairly heavy cut, or else it develops a tough skin. Just can cause you a lot of problems, and likes to break drill bits. So, and reamers, but good material, bearing material for sure. Will last forever if you keep a little bit of lubricant on it. So here's the insert that we used to machine that 430 or 4130, and it is a Walther DNMG 432. These are made in Germany. Got a pretty aggressive little chip breaker in there. Not because I spec'd these for the job. It's because it was what was in the holder, and I've had good luck with these, and it held up really well and gave me a manageable chip and a good finish. So I mean, what else do you need really? Alright guys, that's it this week anyway. Still a long way to go. We have came a long way, but man, everything on this saw that could be broken or damaged is. So, it's not over yet, that's for sure. Still could be some, stuff that we find that needs repair. Although I can't imagine too much more on this saw can be broken. There's just not many parts left. So, that's it. Thanks for watching guys, I really appreciate it. Huge thanks to my patrons. If anybody's got any suggestions, leave them in the comments. Make sure to subscribe to the channel if you haven't. It really helps the channel grow. That's it. Thanks for watching, guys. I'll see you next time.